Correlations are used to determine if a relationship exists between two continuous variables. With our fictitious study, I'd like to determine if a correlation or a relationship exists between GPA and age. In other words, is GPA related to age? To calculate correlation, click Analyze, Correlate, and Bivariate. From the Variables list, move the variables you want to correlate to the Variables box on the right and click OK. So I'm going to select Age, move it over to the Variables box, and then select Student GPA and move it over, and then click OK. SPSS will now run the calculation. In the box in the output document here, we will want to look specifically at the statistics in the cell where the two variables intersect. So in this example, we look at the very last cell in the first row or the second cell in the second row. Looking at the first row, age, we go over to where this row intersects with GPA, and it shows we have a positive 0.715 correlation. Now, correlations can range from -1 to +1. With a positive correlation, we can conclude that as one variable increases, so does the other. If we had a negative correlation, we would conclude as one variable increases, the other variable decreases. In our example, the 0.715 correlation indicates two things. It indicates as the age of the respondent in our study increases, so does their GPA. It also indicates the higher GPAs are more likely to be earned by the older students in our study. Now that we know we have a positive correlation, in other words, as one variable increases, so does the other, the next important question to ask is the correlation statistically significant? Could this happen by random chance alone, or is there something significant we need to note about the correlation? Another way to phrase this is, by random chance alone, what is the chance of arriving at the same correlation between the same two variables in a study with the same number of n? To determine if there is a statistical significance, look at the variable's sig two-tailed number. If this number is below 0.05, then there is a statistical significance in the correlation between the variables, and the null hypothesis should be rejected. Let me repeat what I just said. If the sig two-tailed number is below 0.05, then there is a statistical significance in the correlation between the variables, and the null hypothesis should be rejected. A sig two-tailed number above a 0.05 indicates no statistical significance, and the null hypothesis should be accepted. In our example, the sig two-tailed number is 0.02. So we should report the correlation between age and GPA to be statistically significant. The sig two-tailed also indicates, by random chance alone, the chance of arriving at the same correlation between the same two variables in a study with the same number of observations is 2%.